Hello everybody. So today's lesson is going to cover how to do some word problems and real life situations for systems of equations. So when we're talking about taking the skills that you've already learned and then turning them into something you can use in real life, there are a few questions you kind of have to ask yourself as you go through things. And as long as you sort of follow these 6 questions that we have up on the screen here, and you go about answering them, you should be able to handle any sort of real situation that you're put into. Now, I'm going to go ahead and color coordinate them as I go through as well. So we go ahead and we take a look over the word problems. And one strategy I like to do right off the bat, just to kind of assist myself before I answer these questions, is just go through and highlight or underline any key information that I have. And what I like to do is I take anything that has a number, basically, and I just go ahead and underline it, along with the words that are attached to it. Okay? And one other thing that I do as well, usually in a different color, maybe double underlining, is I take the operation words, things that involve math words, and I can kind of pull them out for myself. So when I look at, for example, is we have the word per here, right? I can double underline the word per anytime that I see it, because the word per in math means multiply. And I mean, sells is kind of an easy one to figure out. If you're selling things, you're going to have to add stuff up. We get that. And we can see how many. That's asking for a total, right? So those are some key information words that I'd pull out in the beginning. The next thing I'm going to look at is how would I answer these questions? What am I finding? So let's look over the word problem. We haven't read it yet even. A store sells 2 flavors of ice cream at a discounted price during its special: mint chocolate chip and Rocky Road. The mint chocolate chip sells for $2.50 per cup, while the Rocky Road sells for $2.75 per cup. In total, the store sells 430 cups of the 2 flavors on special for $1,120. How many cups of each ice cream did the store sell? One word that I did miss here that I would like to point out now is that word total. That's an important operation word too, because that does talk about adding things up to get a overall total. Now that we have that, what am I finding? I'm finding how many cups of each ice cream were sold. What ways am I measuring this? What are the variables? Well, what I talk about in that is, are there different things I'm measuring? Is it just one ice cream? Like, what am I dealing with in the context of this problem? Well, when we saw this, we have mint chocolate chip and Rocky Road. So those were the 2 that we saw. What variables am I going to use to represent these amounts? Technically, you could use any variable you want. I am going to go ahead and put x equals, not double x, but just x. There we go. Equals chocolate chip. Y equals Rocky Road. Do my variables have coefficients? So when we look at the context of this problem, I'm kind of asking, like, is there a cost that's attached to them that I'm going to have to multiply? Keep in mind, when you take a coefficient for a variable, you're multiplying it by something. And that's why in the very beginning of the problem, I double underline that word per. That's a signal word for me. If I see the word per or each, usually talking about multiplying things together. So that tells me that that number that's attached to the 250 that's underneath my typing thing there, 250 and that 275, those are coefficients. So do my variables have coefficients? Yes. Now what's attached to what? Well, the chocolate chip is 250. So I would have 2.50x. And the other one was y, and that one had a cost of 275. So it's 275y. Okay. Are there any additional amounts I should add or subtract to my variables? So are there any starting amounts? Sometimes you'll see these in problems. This particular case, no, we do not have those. We're just talking about each cup, what their price is, how many cups we sold. But we're not talking about adding or subtracting anything to it that's a different amount. So the answer to that's no. What equations represent my given situation? Now, if you have a single variable and just kind of solving a single equation situation, you would come up with the one equation. But in the case of this equation, I have two different pieces of information I'm given. So I'm going to have two equations for the situation. It's a system. The very first thing that I see is the one that I came up with to start, which was 2.50x. And if I add that to the 275y, I would have my total sales. Because if I multiply cost times the amount I sell for things, I can figure out how much I earn. Okay? And there is a second equation that I am given. That is for the total number of cups sold. Not the amount that we earned in money, but the amount of cups we sold. That's also underlined in red. It says that we sold 430 cups. Well, if I know that X is my cups of the mint chocolate chip and Y is the cups of Rocky Road, I sold 430. Okay? So now that I have this, I've gone ahead and rewritten this equation into a system of equations. And now I can use my solving systems of equations methods, whichever is easiest for me, to be able to find the answers to this problem. Now, there are a couple of ways I could go about this. I could use the method of elimination and basically just choose which to eliminate by multiplying and then find one variable at a time. Or I could use substitution. So if you prefer elimination, you would basically just want to pick either the x or the y to multiply here and multiply everything in this x plus y equation, that second one that I have here, by whatever number's in front of the one you want to eliminate. So if I want to get rid of x, I'd multiply everything here by 2.50. Rewrite the equation, then eliminate. If I want to do the y's, I do everything by 2.75, then eliminate. I'm going to go ahead and show you how to do this using substitution. So if I were to look at this equation here, I can rewrite this as, let's go ahead and do x equals 430 minus y. Okay? So I can rewrite this equation to be that, and then I can just take that amount and plug it in. Actually, let's not have that one. Let's do it this way. To there, right? I can take this. I'm going to go ahead and just make this purple. I can take this amount that I'm underlining in purple right here. Oopsie daisies. I wanted my pencil. I can take this right here. I could plug it in here for x, right? So that's exactly what I'm going to do. So let's go ahead and solve for so the 2.50 stays the same. I'm going to go ahead and color code this part right here to the purple, just so we know this is where I'm plugging something in. Because that was what I just got, right? The 430 minus y. That's the part that I just got for my rewritten equation. And now what I'm doing is going ahead and rewriting the rest of this. And this was plus 2.75y equals 1120. And now I just go ahead and go through and solve. So I would distribute this. 2.50 times 430 is 1075. Okay. So now I got this. 1075 minus 2.50y plus 2.75y equals 1120. I would get 0.25y plus 1075 equals 1120. I'd solve this by subtracting 1075 from both sides. I get this, which is negative 45. Or no, excuse me, positive 45. I don't know why I said negative. I think I was looking at my calculator wrong. And then I would divide by 0.25 on both sides. And y would become 180. Okay? So now that I got 180 for y, I can then take that and plug it in here to get $430 minus 180, which would be 250. And the last step I do is just write it out in words. So that way I know what I'm measuring. So the 250 was X, so it was 250 chocolate chip and 180 Rocky Road. And if we were to plug these back in to double check our answer, 250 plus 180 is in fact 430. And if I were to take 250 and times that by, well, I guess in this case it is actually 250. That'd make me $625 plus, if I were to multiply 275 times 180, that'd give me $495, and that would make $1,120, which was the same amount we sold in the beginning. So I know that checks out when I check the math using my calculator. So here in this video, we just basically saw an example of how to work through a real-life context problem using systems of equations. We want to make sure we underline the important information we have, along with the numbers, the operation words. We define variables, we make equations, and then we use the skills we've learned in the previous lessons to be able to take that information and work through it. Now, other things to note just really quick before we end this video. When you get to your assessment coming up, when you get to our large project that's going to take weeks to do, it's going to be your test basically. You're not going to actually be tested, you're going to be doing that. When we get to that, one thing to remember and to keep in mind is that when we have situations like this, like you see how we have like the 250x to 275y, and we're making those coefficients, we're multiplying it by the variables. Keep in mind that if you're measuring something over a given period of time, you always want to take the amount that you're making, whether it's a cost or a salary or whatever the case may be, and you're going to multiply it by the period of time. Cost times amount of time, or cost times hours, cost times days, months, whatever it is you're measuring. That's going to give you the total amount of money you earn when you're creating that first equation, if that makes sense. Okay? So that's just something I want you to bear in mind. Like looking at this skill that I did when I made this system of equations. If you can get to this step, I'm confident you can be able to use those skills that we learned throughout this unit to be able to find these pieces of information in real life contexts.